Believe it or not, a day was only 21 hours long 600 million years ago when some of the first plants and animals roamed the globe. Every 100 years, the Earth's rotation is slowed by 1.8 milliseconds. That may not appear to be much. Those milliseconds, however, pile up over hundreds of millions of years. However, scientists discovered in 2020 that the planet is rotating faster, not slower. This resulted in the shortest day ever recorded while using the super accurate atomic clock to track the length of days. The 29th of July 2022 was 1.59 milliseconds shorter than a normal atomic clock standard 24-hour day. The 28 shortest days on record since we began keeping count 50 years ago occurred in 2020. What does this mean for us? To answer this, let's first understand why the Earth rotates. Our solar system began to rotate some 4.5 billion years ago, when a dense cloud of interplanetary dust and gas collapsed in on itself and caused angular momentum. Essentially, the tendency of a body that's rotating to carry on rotating until something actively tries to stop it. Our globe has been rotating for billions of years due to this angular momentum, and we experience night and day. However, it's not always spun at the same rate. We can find evidence of how each year was jam-packed with extra days by examining growth lines on fossil corals hundreds of millions of years ago. Although days have gradually become longer over time, due in part to how the moon pulls at the Earth's seas, which slows us down a bit, during humanity's watch we've been keeping steady at around 24 hours for a full rotation, which corresponds to around 365 rotations every journey around the sun. Scientists developed atomic clocks in the 1950s to keep track of how electrons and cesium atoms fell from a high-energy, excited state back to their normal state. Because the periods of atomic clocks are formed by this unchanging atomic behavior, they're not thrown off by external factors such as temperature shifts in the same way that traditional clocks are. Over the years, however, scientists discovered a problem. The uniformly accurate atomic clocks were deviating slightly from the time that the rest of the globe observed. Judah Lane, a physicist in the National Institute of Standards and Technology's Time and Frequency Division, said that as time passes, there is a gradual divergence between the atomic clock time and the time measured by astronomy or by the position of Earth or the moon and stars. Essentially, a year, as recorded by atomic clocks, was slightly faster than the same year calculated using the Earth's movement. And to keep that divergence from becoming too big, a decision was made in 1972 to periodically add leap seconds to atomic clocks. Leap seconds function similarly to the leap days that we add to the end of February every 4 years to compensate for the fact that the Earth orbits the Sun in 365 days and a quarter. However, unlike leap years, which occur every 4 years, leap seconds are unpredictable. The International Earth Rotation and Reference System Service keeps track of how fast the Earth rotates by sending laser beams to satellites to measure their movement, among other methods. When the time plotted by Earth's movement is 1 second out of sync with the time measured by atomic clocks, scientists all around the globe coordinate to halt atomic clocks for exactly 1 second, at 11:59 p.m. on December 31st or June 30th, to allow astronomical clocks to catch up. Scientists have added leap seconds every few years since the first one was added in 1972. They're added in an erratic manner because the Earth's rotation is erratic, with intermittent intervals of speeding up and slowing down, which disrupt the planet's millions of years-long steady slowing. Well, basically, the Earth's rotation rate is a complicated business. It has to do with the interchange of angular momentum between the Earth and the atmosphere, and the influence of the ocean and the moon. However, the fact remains that in the last decade or so, Earth's rotational deceleration has slowed. Since 2016, there hasn't been a leap second added, and our world is already spinning faster than it has in half a century. This absence of the requirement for leap seconds was unexpected, according to scientists. The assumption was that the Earth would continue to slow down and leap seconds would be required. Scientists may have to take action depending on how much the Earth's rotations speed up and how long that trend continues. There is this concern at the moment that if the Earth's rotation rate increases further, they may need to have what is known as a negative leap second. In other words, rather than adding an extra second to allow Earth to catch up, we must subtract a second from the atomic timescale to bring it back into alignment with Earth. A negative leap second, on the other hand, would provide scientists with an entirely new set of issues. There's never been a negative leap second before, and the concern is that the software that would have to handle that has never been operationally tested before. Whether a standard leap second or a negative leap second is required, these minute alterations can cause havoc in businesses ranging from telecommunications to navigation systems. This is because leap seconds mess with time in ways that computers aren't designed to handle. The primary advantage of the internet is that time is constant. Things fall apart when there isn't a steady, continuous flow of information. Repeating a second or skipping over it throws the entire system off and can generate gaps in what should be a constant stream of data. Leap seconds also pose a problem for the banking industry, as each transaction must have its own unique timestamp. A possible problem if that 23:59:59 second repeats itself. Some companies, such as Google, have developed their own ways to leap seconds. On a leap second day, instead of stopping the clock to allow Earth to catch up with atomic time, Google makes each second a tiny bit longer. And that's one way to do it, but it's not consistent with the international standard for how time is defined. However, in the grand scheme of things, the amount of time that we're discussing is negligible. We're talking about just 1 second every couple of years. It's likely that you've lived through a good number of leap seconds without even being aware of it. And if we think of time as a tool for measuring things we see in the world around us, such as the passage from one day to the next, then there is a case to be made for adhering to the time that is set by the movement of the Earth rather than the electrons in an atomic clock, regardless of how accurate the electrons may be. Lane believes that leap seconds aren't worth the trouble they cause. The cure is worse than the disease. If we stopped resetting our clocks to account for leap seconds, it may take a century to deviate even a minute from the true time recorded by atomic clocks. It's also true that 12 o'clock noon, the sun is overhead. So even if you don't think about it often, you have a connection to astronomical time. Leap seconds are only a small, almost insignificant means of keeping that bond alive. The constant acceleration of our planet's rotation invites us to consider the brittleness of time itself. Our lives appear to be suspended in an ever-accelerating whirlwind as days blur into fleeting moments. With this realization, we're confronted with the duty of expecting the world to always conform to our expectations. A profound realization emerges in the chaos. Our existence is but a fleeting moment in the grand symphony of the universe. And to adapt to this fast-paced planet, we must learn the secrets of time's fluidity and embrace the fleeting beauty of each passing moment.